Welcome, my name is Mr. Sunarine, and today's lesson we're going to be looking at how do you solve multiplicative comparison word problems involving fractions. Before we get into today's lesson, I wanted to go over some keywords in understanding math word problem clue words. When we're looking at math word problems, at the end of each problem, it tells us what the problem wants us to do. Here are some clues to help us with that. For example, if we're looking at words that have like same, twice, product, in all, double, we're looking at multiplication. If we're looking at share equally, each, quotient, every, then we're looking at division. If we're looking at add, altogether, and, both, in all, sum, total, increase, we're looking at addition. And then lastly, if we're thinking about difference, fewer, gave away, take away, how many more, how many larger, shorter, smaller, left, less, take away, change, decrease, then we're looking at subtraction. We're going to go into a math word problem and we're going to try to work through it and see what the problem is asking. The first problem tells us Natasha's sculpture was 5 3/16 inches tall. Maya's was 4 times taller. So feel free to pause the video, think about what you might need to do, which operation we need to complete in order to get our answer. I'm going to move on to the next slide and I'm going to show you how to work through that problem. When we see the clue word 4 times, in this case 4 times taller, this tells us to multiply. So when we look at the problem, we're going to multiply 4 times the 5 3/16. Here we want to multiply the whole numbers together, so 4 and 5. And then we want to multiply the 4 with the numerator, so 4 times 3. Here we get 5 times 4 gives us 20, 3 times 4 gives us 12, and the denominator stays the same. Here's another explanation that I just went over. Multiply 4 to the whole number 5 and the numerator 3. Next, we're going to look at part 2 of the problem. And in this problem, we already got the first part's answer. And now we're going to look at how much shorter was Natasha's sculpture than Maya's. So again, pause the video, think about what you might have to do to get to your answer, and we're going to move on to the next slide. When we look at the problem, it says how much shorter. That tells us we need to do subtraction. I've provided the answers from the previous slide, and what we need to do is we're going to subtract the two numbers, in this case the two different fractions, and here are some steps. In case if we're having trouble subtracting fractions, you subtract the whole numbers and you subtract the numerators. Here, 20 and 5 are our whole numbers, and 12 and 3 is our numerators. When we do that, we end up getting 15 9/16 as our answer. And our final answer would be Natasha's sculpture is 15 9/16 shorter than Maya's. Okay, we're going to go over a new problem. In this example, we look at a seamstress needs 1/5/8 yard of fabric to make a child's dress. She needs 3 times as much fabric to make a woman's dress. So pause the video, think about what you need to do in order to get to your answer. We're going to move on to the next slide to show you that. Here, we notice that you need to do 3 times, which tells us multiply. So here, we look at you multiply 3 to the whole number and the numerator. Same thing as our previous step, the previous problem that we looked at that. And notice here that when we're multiplying, 1 times 3 gives us 3, 5 times 3 gives us 15. We have 15 over 8, which is an improper fraction. When we could break down 15 over 8. Here's an example. 15 over 8 breaks down into 8 eighths and 7 eighths. We know that 8 over 8 is just 1, and 7 eighths we can carry over. That's why we have 3 plus 1 7 eighths, which gives us 4 7 eighths. And our final answer would be 4 7 eighths yard of fabric is needed to make the woman's dress. Now we're going to move on to part 2 of this problem. How much yards of fabric does she need to make both dresses? So pause the video, think about how you might want to work through this problem, and we're going to look at a keyword that will help us in determining what operation we need to do. Here we see that she needs to make both means addition. So we have the information for the child's dress here, and we have the information about the woman's dress here. So we're going to add those two fractions together. And again, we add whole numbers and numerators together. So here we have 1 and 4, 1 plus 4, and then we're going to add the numerators, which is 5 and 7. So when we do that, 1 plus 4 gives us 5, 5 plus 7 gives us 12. We don't do anything with the denominator. We leave that as an 8. And what we'll notice is 5 12 eighths. The 12 eighths we can simplify out because it's an improper fraction. I brought the 5 down here, but we're just gonna rewrite it. 12 eighths breaks down into 8 eighths and 4 eighths. So we know that 8 eighths is 1. So therefore 1 plus 5, which are our whole numbers, is our 6. And then we carry over the 4 eighths. Therefore, in order to make both dresses, the seamstress needs 6 4/8 yards of fabric to make both the child's dress and the woman's dress. Now we're gonna summarize this information. How do you solve multiplicative comparison word problems involving fractions? The first thing we need to do is read the math word problem carefully. There's certain key information there that will help us determine what operation we need to do. For example, when we see 3 times, that means we're going to multiply 3 times. If we see 4 times, we're going to multiply 4 times whatever the value we're working with. Here are some examples that correspond to those examples. Hopefully this was helpful, and have a great day.